Hello, my name is Gyanendra and this video is about graphs and how to visualize them using Python. Python is a very simple language. For example, we can think it like uh, we are talking to a computer since its commands are just like what we speak in normal language. Now, since this video is about graphs, so a brief introduction of what graph is. As we can see in the slide, graph is a pictorial representation of a set of objects where some pair of objects are connected by links. The interconnected objects are represented by points termed as vertices, and the links that connect the vertices are called edges. uh, Image you can see, for example, a b c d, all these are called vertices, or another term used for them is nodes, and the line which connects them is called edge. In simple language, we can say that it's a pair of set v comma e, where v is the set of vertices and e is set of edges connecting the pairs of vertices. Like we have seen in the previous image, uh, a, b, c, and all these are vertices. So V is a set representing all these vertices, and E represented the set of edges. A is connected to B with an edge, so we can see AB. Similarly, A to C, C to D, D to E, and etc. Now we know there are various types of graphs like complete graph, directed, undirected, and acyclic path graphs. So basically, for understanding this video very efficiently and understanding the concept effectively, you need to have some prior knowledge of both Python language and the concept of graphs. uh, for Python, I am currently using Jupyter Notebook. It's my favorite one, and you can either use Sublime Text, Atom Editor, or Python ideally. Anything what you like. So let's begin. In order to see or work in Python, or to see what makes the graph, we need to import a few packages, or we can say like libraries. We need to import three of them. Let me just type it. So as we can see, I have imported three packages: Networkx, NumPy, and Matplotlib. So basically, we can say like these are the three packages which help us to see graph and visualize them. For Networkx, it is a Python language software package for the creation, manipulation, and study of structure, dynamics, and function of complex networks, or we can say graph. It provides us tools for study of structure and dynamics of networks or graph, provides a standard interface and graph implementation using various standard graph algorithms. For working with this package, we need to know that Python version 2.7 and above. The all these packages are work only in these Python versions and not the older ones. So be aware of that. Similarly, matplotlib package is imported in order to see the graph. Like in simple terms, we can say to visualize a graph, we use this package so that we can see how exactly the graph looks like. And NumPy is a general purpose array processing package. It provides high performance multi-dimensional array objects and tools for working with these arrays. So all these technicality and definitions, leave all of them. Just for exam purpose, for knowledge, we need to work on the code. Now, in order to create a graph, we have a graph function. Like for example, let's name the graph G. And to create that graph, we have a function called as graph function. As I previously said that Python language is just as similar as we are talking to someone, and so the method is like this. And we can clearly see using this, and let's execute it uh, and run this. Okay, so we see that there is no error. So let me explain this. G can be set as the name of the graph, and NX is like the concept we use in SQL, like table aliases. It's like a shortcut and a short name given to a package's name. For example, in this case, we can see a matplotlib.pyplot, and it's a very big name. So typing it again and again is difficult for in long codes and everything. So we give it a short name, a shorter version, like a nickname. So NX is the nickname of Networkx package. As we can see, there is no error. So the graph is created. Now we know graph consists of nodes, edges, and etc things. So to create a node or to add a node, we have a function like by the name add node and 1. This is how it goes. So let's add like 5 nodes in this. Let me paste it like 5 times. So it's now we can see I've written the add node function 5 times, 1 2 3 4 5, and these are the nodes. We have made 5 nodes, and the graph will consist of 5 nodes. Now if we check whether this will show an error or not, we will run it. And okay, it's not showing any error. That's great. And to know what nodes we have added, we have a function by the name uh, nodes, and it's written like g.nodes function, and we will run it. So as we can see that we have added 5 nodes, and it's showing 1 2 3 4 and 5. Now as we know, graph also has edges, so we have a function called as add edge, and it's written like g dot add underscore edge, and in bracket we like write the starting and ending point. Like we want an edge between 1 and 2, so we will write 1 comma 2. And let me just edit and add edges between all these vertices. I have written the code, and as we can see, and expect the output to be an edge between 1 and 2, 1 and 3, 1 and 4, and 1 and 5. So let's run this cell, and it's not showing an error, so it's great. So like previously we did for nodes, to view the node, we have and another function to view the edge. It's like g dot edges, and let's run it. And we can see 1 comma 2, and it shows further also. Now to visualize this and see the graph, like an image of the graph of what the graph will actually look like, we have draw function, and we for that we need to use the Networkx package, and the syntax goes like nx dot draw, and inside the bracket we will write the name of the graph. And let's run this cell, and as we can see, this crossed graph, this is how the graph looks like after using the draw function. As we can see, the nodes without a name or a label are just meaningless, and they are just a drawing with no meaning. So we will add a label. So in the same function, we can write with labels equal to 1. So for example, just for understanding, we can say that 1 will be the starting number and all else will be auto incremented. So let's run it, and we can see that 1, 2, 3, 4, and 5. So all the labels, all the nodes have a name. Now for, we can say, certain kind of decoration or for assignment purposes, we need to make like change the color of nodes and edges. So we have functions like just similar like with labels. Instead of with labels, we can write node color, node underscore color. So we need to make sure that the spelling of color is color instead of COLOUR. In coding languages, usually the spelling of color is used as COLOR. So for example, we need orange color. So equals orange, and edge color underscore color, let's make it green, for example. And let's see, let's execute this cell, and as we can see, the color of the nodes and edges have changed. Now we can also directly add a node. Instead of writing this function add node and then adding an edge between them, we can directly like write it g dot add edge, wait, g dot add edge, let's make a node between 5 and 6. And so let's write 5 comma 6, and let's run this cell, and use nx dot, uh, wait, let's just use this previous command, uh, run. So we can see that without adding the node and then writing a command individually for both the cases, for adding node and adding edge, we can directly write the add edge command. So we can insert a node also using this. Now we have a few predefined functions, like for example, if we want a path graph of let's say 9 edges, so let's name the graph as P, and and using nx dot path underscore graph. Path underscore graph is the predefined function, and it takes the input like 8. And on running this cell, and then use nx dot draw p. So after executing it, we can see we have 8 nodes, 1 2 3 4 and 8. Okay, so so let's add label names and change the colors too, just for practice purposes. And let's run this cell. Okay, so we can see the numbers have changed and the edge colors too. So this is how a path graph looks like. And similarly, we have function for a cycle graph, and it goes like nx dot, just wait, and for cycle graph we have a function, let's name it c equals nx dot cycle underscore graph, and we need like let's say 6 vertices slash nodes, and let's run it. And okay, so it's not showing an error. And using sorry, nx dot draw c, and let's run it. Okay, so we can see it's a cyclic graph. Actually, you might be thinking that this point is the intersecting one. So let's run it again. And okay, so the shape has changed, and we can visualize. As the definition of cyclic graph says that uh, it forms a cycle, as the name says. Similarly, we have a function for a complete graph of like, let's say we will make a complete graph of 9 nodes, and let's name it D. Okay, so using nx dot complete underscore graph, and we make it like of 9 nodes. Okay, so let's run it. And okay, it's not showing error. It's great. And using nx dot draw, sorry, spelling mistake, and d. Okay, and let's run it. See, we can see, it might be a little difficult to visualize it, but as the definition of complete graph says, that each node is connected with another node. So in order to understand this and visualize it perfectly, we will make a graph of 4 nodes. It will be a lot easier to visualize it. Let's name it h, and nx dot complete underscore graph, and let's give it a number 4 and run it. No error. Nx dot draw h, and let's run it and see, each node is connected with another node, so as the definition of complete graph is satisfied. Similarly, we have various functions by, like if we want to make direct graph, we have digraph and various methods same like this. So this for this video lecture, this is all it. And thank you for your time. Like, share and subscribe. Jai Hind.